Hello and welcome to our video solution to problem 11 from Superquiz 3. This was the last of the required problems, so the next several videos will be about optional problems. And this is a standard result from very beginning ring theory where we prove that if in any ring where the additive identity is denoted by 0, then if you multiply by 0 in that ring, you must get the 0 element back. This is something we tend to take for granted because we're used to working in the integers or the rationals or the reals where multiplying by 0 always does give us 0, and we don't even think about why that might be true. But if you're in an arbitrary ring, the fact that 0 times anything is 0 requires a proof. It's not one of the ring axioms. So there's probably a few ways to do this. This is sort of one of the standard ways to go. So we can start by multiplying 0 by x, and then, of course, we can break this 0 up as 0 plus 0. That is one of the ring axioms. If we add 0 to anything, we get back the same element. So 0 times x will be the same as 0 plus 0 times x. Now, another one of the ring axioms is distributivity, which tells us if we add two ring elements and then multiply them by a single ring element, that will be the same as if we individually multiply those two ring elements by that one ring element, so 0 times x and 0 times x, and add them together. Now, we're not assuming that 0 times x is equal to 0. We just assume it's equal to some element. It's some element in the ring. So maybe we'll call it, I don't know, u. So our equation then becomes u equals u plus u. So u equals u plus u. But one of our other ring axioms is that every element in the ring has an additive inverse. So u itself has an additive inverse, so we're going to add that additive inverse to both sides. So u plus the additive inverse, which we denote by negative u, will equal u plus the additive inverse of u. And again, because we're working in a ring, we have associativity, so I can put some parentheses here to denote I'm going to add these two first. All right, u plus its additive inverse, that by definition is equal to u. Equals, okay, we have u plus, well again, we have u plus its additive inverse, which is a 0. But again, one of our ring axioms, anything you add to 0 will get back itself, so u plus 0 is equal to u. And so we conclude that u is equal to 0. Well, what was u? Right, u was our 0 times x. So we conclude 0 times x is equal to 0.